So what about when I try to solve a system of linear equations and I can't find a solution? What are the different options? Well, before we look at 3 dimensions, let me remind you of 2 dimensions. Obviously, if I have 2 lines in 2 dimensions, one of the options is they can intersect at a particular point. We call that the unique solution. Or the lines might be parallel, in which case there is no solution. We might call this inconsistent. Inconsistent equations means the equations have no solution where they both meet. Or we might have the 2 equations actually describing the same line. The lines we say are coincident, they coincide. And the solutions we say are indeterminate. There's an infinite number of possible solutions. We can't determine which one is correct. In 3 dimensions, it gets a bit more interesting. In 3 dimensions, what we're actually doing is looking at 3 planes. Each equation, something x plus something y plus something z equals a constant, describes a plane. Those 3 planes might intersect at a single point. There's only one point in common for all 3 planes. That point would be our single unique solution. But sometimes there might not be a solution at all. So if at least 2 of these planes are parallel, then those 2 planes are never going to intersect, so there's no solution. The 3rd plane might go through them, or the 3rd plane might itself be parallel to those 2. In this case, there is no single point common to them because there's actually no points common between these 2 planes. Then again, we call this inconsistent. There's no way to have a point that's on all of the planes at once. There's no way to have a point that satisfies all 3 equations at once. There's another way of having this. I can have each pair of planes intersecting in a line, but those lines where they intersect might themselves be parallel. So I can have non-parallel planes that still have no common point. This is still inconsistent. There could be an infinite number of solutions if the planes are actually describing the same plane. If the equations are actually describing the same plane. We would say those planes were coincident. The planes coincide, they're the same plane. Then obviously there's no way to choose. There could also be infinitely many solutions if the planes intersect in a single line. Then again, there's an infinite number of solutions all along that line. Whichever of they, in both of these cases, we say that the solution is indeterminate. I can't determine a single solution.